This is the grammar for Mo with variables. It's simpler than before because we've gotten rid of box, unbox, and setbox. So now instead, every identifier is implicitly a box, and we can directly do an assignment with the colon equals operator, and that takes the place of setbox. And finally, same as last time, we have begin expressions to sequence two expressions, one after the other. So here's one example program that we can write using this grammar. Let b equals 0. Now b is a variable. Begin b colon equals 10. So we update the value of b, and then when we read that out, we should get the final result of 10. Let's look at a few more examples. So the signature for our interpreter will be the same as last time. We take in an expression, an environment, and a store, and we'll return a result. And the result combines the value with the store. Here's a first check. If we have the int expression 5, then interpreting that should give us exactly the int value 5. There should be no change to this program. And the store we get back should be the empty store, same store that we had going in. Here's a slightly more interesting example. So if we say let x equals 5 and then get the value of x, now we're declaring a variable. First of all, our result should be 5 because that's what x points to. But second, we need to update the store. So there should be a location inside that should point to that value, 5. And that's all that there is in the store. So we declared one variable, we get one mapping in the store, one cell. Now, how about the variable x just by itself? As a plain Mo program, this would be a free identifier. This would be an error. But since we're testing our interpreter, we get to choose what environments to pass in. So we can make this not be an error by passing in a non-empty environment. So we'll bind x to something, and that something needs to be a location which has a match inside the store. So here we're binding x to location 1. Then in the store, we need to map this location to some value. We can choose any value that we like, so let's do the number 5. So now what should the result be? Well, we should get back the value 5, because that's what x points to once we go through the environment and then use that to access the store. And what should the store be at the end? Well, that should be the same store that we had going in. The store shouldn't change, but from referencing a variable. Okay, one more. Here we have a function that takes in one input, x, and adds it to itself. And then we immediately call that on the integer 8. And we'll evaluate this program with the empty environment and the empty store. So the result that we expect is 8 plus 8. And the store that we expect should have at least one cell in it. So it needs to map a location to the value 8 that we pass into the function. Because remember, that parameter x, that needs to be mutable inside the function body. So we need a cell for that. And with that, our store is complete. So we have one binding in the store for this one. And this is the same behavior that we'd expect from the program down at the bottom, which uses boxes instead. So once again, really what we're doing is translating code that uses variables to behave like code that uses boxes.